can actually extend our lifespan to potentially things that people can't even imagine.
Wow.
It turns out that 90% of all the cells that make you and me are actually non-human cells. They're bacteria, viruses, funguses that live in us and on us.
Wow.
And the shocking thing is that 99% of all the genes that make up you and me are non-human genes.
What are they?
They're bacterial and viral genes. And what we've completely missed from the Human Genome Project is that we have actually very few genes, and our genes are about 99% the same as a chimp or a gorilla. And we're very different than chimps or gorillas, yet we have virtually the same genes. What makes us different is actually the bacteria and viruses that live in us.
So different bacteria and viruses.
And you can actually show when humans evolved from the other great apes that our bacteria actually changed, and we can actually identify that point in time that the bacteria made us rather than our genes made us.
The bacteria made us rather than our genes made us.
The bacteria made us.
So the bacteria made us human, or bacteria made us...
Yeah, they actually, as shocking as it may seem, most of what happens to us is determined by the state and the variation of our bacteria, primarily in our gut. Give you an example. You can take bowel movement from an obese individual and feed it to a skinny rat.
Right.
And those skinny rats will become fat.
Really?
Because the bacteria have actually manipulated their feeding habits. They actually send text messages to the brain to go look for foods that they would not otherwise consume that those bacteria want. And there's a woman marathon runner in England a couple of years ago who developed severe infection in her colon. And the modern treatment of this now is a fecal transplant. So they found a cousin who was a good match for her, and she got the fecal transplant. And in the next year, this marathon runner gained 32 pounds without changing anything. And it turns out her niece was actually about 32 pounds overweight. And so she was inoculated with obesogenic bacteria. And her bacteria, these little, one-cell organisms, controlled her behavior.
Wow.
Now, think about that.
So it made her more hungry or desirable of certain foods?
Yeah, exactly.
So she changed the way she was eating because she was triggered in
being manipulated.
Wow.
Being manipulated. So these things actually, the obesogenic bacteria can actually live on them. They love it. They love simple sugars. They love saturated fats. And they go, yeah, give me more. And they actually tell our brain to do that. It's kind of like, you remember a movie, Little Shop of Horrors? And there's this blood-sucking plant that grows, and Audrey keeps getting bigger, and Audrey has to have human blood. Audrey says, feed me, Seymour, feed me. And it turns out that this whole concept is actually true, that our bacteria control our behavior. For instance, you can take depressed mice and put their bacteria in happy mice, and those happy mice will go hide in a corner and not come out. In fact, in the 1930s, back in those days, most really depressed people were institutionalized. So they did an experiment where they gave them all colonics and cleaned out their colons, and then they gave them fecal enemas from happy people.
No way.
And about 2/3 of the depressed people got happy and were released. In the 1930s.
Wow.
So, I mean, it's just, you start looking at this and go, whoa, we're probably looking at the wrong stuff. For instance, one of the things that I'm talking about in Berlin in October at the World Congress of Microbiota, that's what this study is. We now know that you can take bacteria from young animals' guts and put them in old animals' guts, and the old animals will become young again.
No way. I mean,
it's the fountain of youth.
No way. So their cells will get younger?
Yes.
Or they'll have youthful energy, or what?
All of the above. They will actually extend their lifespan by about 30%.
What?
Yeah, because here's the deal. What I'm trying to get people to understand is this is not about you and me or what we conceive as us. We're just a condominium for the people who really run us, and these are all these little one-cellular organisms. And what we're beginning to realize is we're a condominium for these bugs. And we're their home. We've exchanged them living in us and actually taking care of us for food and shelter for them.
Huh.
And
that's crazy.
I know. And the really cool thing is, so we can take bacteria from young animals, and put them into old animals. And the bacteria say, man, this place is decrepit. I need to do a complete total renovation here because this is where I'm stuck and I better make the best of it. And I want everything to be nice. It's like, gentrification of the neighborhood. So they actually instruct, here's the take-home message. They actually send text messages to the mitochondria. And you probably know all about mitochondria, the little energy organelles.
In the brain, right?
In every one of you, but the brain has the most of them. And these produce energy. These mitochondria are actually engulfed bacteria. And as strange as it may seem, the bacteria in your gut send text messages to the mitochondria that say, guys, new sheriff's in town, clean up your act. We want you guys working and humming on all, 8 cylinders. It's kind of like General Kelly coming into the White House and total disarray, and it's going, okay, guys, no more of this silliness. And so we now have discovered some of those compounds that the bacteria in your gut signal the mitochondria to regenerate themselves, and it's opening up whole new areas that we never even dreamed of.
Wow. So you're really like 170 years old, huh?
Yeah. Well, people...
So you've just been manipulating all this for the last 15 years
I'll show you a picture when we're all done of me and Mehmet Oz standing together when I did a show a few weeks ago. And one of us is 12 years older than the other person. And you would not guess by looking at our skin who's the old person and who's the young person.
Wow.
And I was showing this picture to David Sinclair from Harvard, who's one of the great anti-aging researchers in this country and actually in the world. And we were discussing some ways to manipulate mitochondria in the brain. And I said, let me show you a picture. And he's looking and he says, okay, so Mehmet's a lot older than you, right? And I said, here, let me show you my driver's license. He said, wait a minute. How old are you?
Right.
And he said, can I have this picture? And I said, yeah. He says, I'm going to put it in all my talks. Because what I've been doing for the last 17 years is giving my bacteria what all the research that I've done and many other people have done would predict that my bacteria are pretty doggone happy with what I'm doing for them.
Wow.
And they're exchanging that happiness to say, man, this is a great place to live, and we're going to keep this place
nice
and just happy.
Yeah.
And so,
And so you lived in a blue zone, is that right? Then Loma Linda?
Yeah, Loma Linda is a blue zone. That's correct. So, but when I was living in that blue zone, I was eating a low-fat vegetarian diet. I was running 30 miles a week. I was one of these Clydesdale runners. I weighed 70 pounds more than I do now.
Really?
Yeah, I was a Clydesdale.
There's a lot of unhealthy people in blue zones, too.
Oh, yeah.
And the vegans that just are overweight, and you're like, how are you this overweight?
Yeah, well, it actually is because you're giving your bacteria the wrong stuff. And that's really part of the plant paradox. The plant paradox is that there's certain plants that absolutely positively do not want us to eat them. Plants have the same evolutionary drive as animals. They want to grow, and they want to have babies, seeds.
They want to protect themselves.
And they want to protect
themselves. They don't want to die.
Exactly. Right. So when animals arrived, they had a problem because animals can run, they can hide, they can fight, but plants are stuck. But plants are chemists of incredible ability. So what they use is chemical warfare to defend themselves and to even make animals do their bidding. Because, for instance, I'll just throw out an example. Most plants want you to eat their fruits because the fruit contains seed to go reseed them.
Yeah.
So you'll eat their fruit. The seeds in the fruits are inedible, and you'll either spit them out, or if you swallow them, they'll survive going through your intestines, and you'll poop them out someplace else.
Fertilized.
And with fertilizer. It's perfect.
Yeah.
And they're away from mom and dad. So, for instance, if an apple falls underneath the apple tree, that poor kid doesn't have much of a chance because mom or dad is going to shade them the next year. But if it gets carried off, even 100 feet away, and then it gets dropped, the plant does this on purpose.
Crazy.
And in fact, you and I love fruit because you and I were designed to eat fruit once a year in the summer to gain weight for the winter. So it was a really good trade-off between, for instance, great apes and plants. But the fascinating thing is manufacturers, food chemists know this, and we are drawn with color vision. And only animals that are fruit predators actually have color vision because you want to know when the fruit is ripe, when it has the highest sugar content.
Right.
And the plant wants you to know when it's ripe because that's when the seed finally has an impenetrable shell. And it doesn't want you to eat it before that time. So it tells you, okay, now's the time.
It's the shiniest object, it's time to eat it. Yeah.
So what colors does it use? In general, it uses reds and oranges and yellows to denote ripeness. So the next time you're going down the snack aisles looking for all the great munchy stuff, you'll be shocked that most of the companies use oranges, reds, yellows to get your attention because it goes direct into the deep center of your brain and says, that color means I should eat it. I'm going to get a lot of calories, and I'm going to be the big winner for the winter.
Wow.
Yeah.
If you're doing that every day, for
Big
many years in a row,
Yes.
you're always storing fat for the winter.
That's exactly right. And that's part of the plant paradox
Yeah.
is that once upon a time, we only had fruit in a very limited time period.
Now we have it accessible all the time.
There were no 747s bringing blueberries to Costco in February. They just weren't. So one of the weird things about our computer program is, like Tony Robbins is always fun to say, we run version 1.0 of our operating system. We've never had an upgrade. And the same goes to the foods and the plants and the fruit we eat. So we were supposed to eat fruit once a year. And when we were eating fruit, our brain says, oh my gosh, it's summer. Winter is right around the corner. You know, we should eat this stuff because winter's a tough time, whether it's dry season, a rainy season, a cold season. And we better store up fat. Just like a bear. You know, bear's eating all those blueberries and huckleberries, and they're storing fat for the winter. Right. So if you're eating blueberries at Costco in February that came from Chile, your operating system doesn't know it's February. It says, heck, it's August, and winter's right around the corner, so I better eat some more of this stuff. And this is one of the things that's happening to us in particularly American society, but now most of the Western countries.
Yeah.
We're eating things that we have no business eating 365 days a year. And most of us are just getting ready for the winter that never comes.
Especially if you live in LA.
Yeah.
It's never getting cold.
Yeah, never comes.
You don't need to store that fat.
You really don't. Yeah, but that's part of the problem.
Wow.
So,
what are the main plants that we should never be eating then?
Okay, real quick. Up until 10,000 years ago, we lived primarily on the leaves of trees, and we ate tubers that grew in the ground, like a sweet potato, for a yam.
Love those.
Yeah, they're pretty darn good for you. You were actually designed to eat them. And 12,000 years ago, 10,000 years ago, we switched over to things that we had never eaten before. And those were the grains of grasses and beans. Now, the reason we'd never eaten them before is, number one, we didn't need to. There's never been a documentation of an ape eating grass or grains. Beans are so lethal that 5 raw kidney beans will kill a human being in 5 minutes by coagulating their blood.
What?
5 raw kidney beans.
Raw kidney beans.
In fact, most people have heard of the poison ricin. So ricin is the lectin of the castor bean. A lectin is the plant defense system. These are proteins that are designed to basically kill us in one way or another. And so ricin is so powerful that about 4 molecules of ricin will kill a human being instantaneously. There's a great study that was written up in one of the journals about a few years ago. They decided to have a healthy eating day in Boston. Yeah. And they served the kids beans. And because it's so healthy. Yes. And they had 30 or 40 admissions to the hospital.
No way.
Beans, we're not supposed to eat those. So
no beans.
No beans.
0 beans.
Black beans. Pinto black.
None of it. We shouldn't be eating it.
Shouldn't be eating it. You weren't designed to eat it. You have no defense system.
No matter how it's
against
cooked.
it. All of us have the power to heal ourselves. Now, the guy who said this was Hippocrates. And Hippocrates, brilliant. He believed that any organism had the ability to have perfect health. And that every organism had the ability to achieve perfect health as long as the obstacles to perfect health were removed. And Hippocrates believed that the physician's job was to identify the obstacles to that organism having perfect health, the patient, and remove them from the patient. And the patient would do the rest. What I try to do, I basically do detective work. And I think I'm pretty good at finding the obstacles. And many of those obstacles, believe it or not, are lectins. And the other obstacle is you got to get the gang members out of your gut by basically starving them to death and giving the good guys what they want to eat.
Starving them of the lectins.
Starving them of simple sugars.
Yes.
And lectins.
You remove those things.
Yeah. They have nothing to eat. Well, it's because their bugs that could defend them are gone. And a cashew. A cashew is a nut too.
I can't eat cashews?
No. The Amazonian Indians always threw the cashew bean away.